We will see postulates of Bohr's theory. The first postulate states that electrons are revolving around the nucleus in circular orbits, and these orbits are basically discrete in nature and they are called stationary orbits. Electrons revolve in circular orbits around the nucleus. These orbits are discrete and they are called stationary orbits. Next, the second one states that as long as the electron is revolving in a stationary orbit, it does not emit radiation in the form of electromagnetic wave. So, that is the second one. When the electron revolves in a stationary orbit, then it does not emit radiation in the form of electromagnetic wave. So, that is how a stationary orbit is. As long as electron is revolving in a stationary orbit, it will not emit any radiation in the form of electromagnetic wave. Therefore, it will never lose energy in the form of electromagnetic wave. The energy of electron in a given stationary orbit remains constant. Next, the third postulate tells you about the definition of stationary orbit. Any orbit for which the angular momentum is an integral multiple of h by 2 pi is known as a stationary orbit. That is, an orbit for which the angular momentum is an integral multiple of h by 2 pi is known as stationary orbit. That is, suppose if L represents the angular momentum of electron in a given orbit, then this L should be integral multiple, that is n multiplied by h by 2 pi. Here n stands for any integer 1, 2, 3 and so on, and h is Planck's constant. That is the equation. As long as an orbit satisfies this condition, it is known as stationary orbit. Now, another postulate states that see, there are observed emission of radiation from atoms, that is when an atomic gas is excited, then it will emit radiation. That happens because when electron undergoes a transition from higher energy level to lower energy level, during the process energy is emitted in the form of photon. That is, the fourth postulate says that when an electron undergoes a transition from higher to lower energy level, then energy is emitted in the form of radiation. For example, if you take E1 is a lower energy level and E2 as a higher energy level, then the difference in these energy levels, that is E2 minus E1, is given out as the radiation. The photon of the radiation has energy of h nu. Therefore, h nu should be equal to the difference in the energy levels E1 minus E2. So, these are the Bohr's postulates using which several phenomena can be explained, particularly the hydrogen spectrum is successfully explained based on the hydrogen atom, Bohr's atom model. But there are limitations for Bohr's atom model also, like this theory cannot be applied beyond hydrogen atom, that is any atom with more than one electron, you cannot explain its spectrum based on Bohr's theory. Even helium atom spectrum is beyond the scope of Bohr's atom model. Now, using Bohr's theory, we can calculate radius of nth orbit for a given atom. The expression for this one is Rn stands for the radius of nth orbit. It is equal to that is the expression Rn is equal to n square h square epsilon naught divided by pi m e square. In that all the terms have usual meanings, like n is the number of the orbit, h is the Planck's constant, epsilon naught is the permittivity constant, and m mass of electron, and e charge of electron. Similarly, we can also calculate the energy of an electron in a given orbit, say nth orbit. That required expression is En, the energy of electron in the nth orbit, is given by this is the required expression for the energy of the electron in a nth orbit, that is minus m e power 4 divided by 8 epsilon naught square n square h square. And the minus sign indicates that electron is a bound particle, it is bound to the nucleus, it is not a free particle. So, we can apply this concept and this expression for a hydrogen atom and determine the radius of a given orbit. For in case of hydrogen atom, radius of the nth orbit will be 0.53 n square in angstrom units. For example, if you take the first orbit, then this will be 0.53 angstroms. In place of n substitute 1, you will get that one. Similarly, if you want to calculate the second orbit of hydrogen atom, then n square will be 2 square, that will be 4 multiplied by 0.53, that is the radius of the second orbit, and so on. You can calculate radius of the any orbit, given orbit, using that expression. Similarly, we can calculate the energy of an electron in a hydrogen atom for a given what you say orbit. It comes out to be something like this, minus 13.6 divided by n square electron volts. That energy is expressed in units of electron volt, that is minus 13.6 divided by n square electron volts. For first orbit, if you take this one E1, this will become minus 13.6 electron volts. N is taken as 1, you will get that much. For the second orbit E2, obviously n is 2, here you need to substitute 2 square, that will become 4, minus 13.6 by 4 comes out to be minus 3.4 electron volts, and so on. Like that, we can calculate the energy values of various orbit in hydrogen atom using Bohr's theory.